Hi, I'm Wesley Wride. This is my video on relativistic momentum and energy. To begin, I'd like to cover some principles about relativity using this time dilation graph. The x-axis here is velocity over the speed of light, which means as our velocity approaches the speed of light, we get 1. Here we have the change of actual time over the change of time at rest. And when the actual time is the time at rest, we have 1. This red line shows us what classical physics teaches us, which is probably what most of us have learned, which is that the change of time stays constant regardless of speed. However, reality and the relativistic line here shows us that as we approach the speed of light, time increases compared to time at rest, approaching infinity. Now this is also true of mass. This is a mass dilation graph. We have the same thing here, speed over the speed of light, and mass over mass naught, which is the mass at rest. Here again, when velocity is 0, we have mass at rest, and so it will be the same thing, mass at rest over mass at rest, which is 1. However, as we approach the speed of light, again, reality, the relativistic line here shows us that mass will increase and approach infinity. We've probably seen this equation before. However, when it was taught to me, at least, they did not explain that mass, as we approach the speed of light, will approach infinity. And so the actual equation is, or a different version of the equation, is mass at rest, c squared, all over the square root of 1 minus velocity squared over c squared. This is also true of momentum. Again, the classical equation we learned is mass times velocity. However, mass is relativistic, which means that momentum and energy are also both relativistic. And this equation shows us that. Mass at rest times velocity all over the square root of 1 minus v squared over c squared. And we see here in both of these equations that as v approaches 0, then momentum will equal that classical equation that we learned. Mass at rest times velocity, and energy as well, mass at rest times c squared, will equal that classical equation that we learned. However, as velocity approaches the speed of light, then momentum approaches infinity, energy also approaches infinity, and mass approaches infinity. And so, if you do a bunch of algebra using this energy total equation plus the kinetic energy, or using the kinetic energy and energy at rest equation, and this momentum equation, you get the relativistic momentum and energy relation, which is E squared equals m naught c squared all squared plus momentum times the speed of light squared. I'm sure this has many uses. I only know of one because my research is very limited, which is to help us find the energy of light. As we know, photons do not have mass, and so using the E equals mc squared equation doesn't give us any energy, which isn't true. We know light has energy. So if we make mass 0 in this relation, then we have energy squared equals momentum times the speed of light squared. We square root both sides, we get energy equals momentum times the speed of light. Now again, if we use this equation for momentum, then we will get 0 because of the mass here. However, we have another equation for momentum, again using a bunch of other equations and doing some algebra. We have Planck's constant divided by the wavelength of the light that we have equals momentum. We plug that in here, multiply it by the speed of light, and we can find the energy of whatever light we have. And thank you.